For today's opener, I'd like you to expand x plus y quantity to the 5th power. You may want to hit pause and work that out. Okay, you probably didn't hit pause, did you? Because you don't feel like multiplying all that out. Well, let's start multiplying it out and see what we get. So we're going to get x plus y times x plus y times x plus y times x plus y times x plus y. Well, that seems easy enough. Let's start with the first two. We're going to get x squared plus 2xy plus y squared. Takes care of those. Now let's multiply by the next x plus y. That's going to give me an x cubed plus 2x squared y plus xy squared. And then plus, so I multiplied the x times everything. Now I'm going to multiply the y times all of those. That's going to give me x squared y. I'm going to put it underneath this one. Plus 2xy squared. Just lining up the like terms. Plus y cubed. Combine like terms, I have x to the third plus 3x squared y plus 3xy squared plus y to the third. Okay, that takes care of the first three. Now I still have to multiply some more. This is going to take forever. But fortunately for us, there's a pattern to what's going on here. And Pascal's triangle can help us out with this. When I do x plus y to the 0, that's just equal to 1. When I do x plus y to the first, I get x plus y, or 1x plus 1y. When I do x plus y squared, I get 1x squared plus 2xy plus 1y squared. Notice the coefficients. Those are the ones that are showing up in this triangle. X plus y cubed, we just figured that out. That's 1x cubed plus 3x squared y plus 3xy squared plus 1y cubed. So notice the coefficients here in this triangle are giving us the coefficients of each of our terms. Also notice, let's put an arrow here. Notice the pattern for our variables. We start out with x, so when I'm doing x plus y cubed, I have an x cubed. The next one, I'm lowering my x exponent by 1, x squared, and I'm increasing the y exponent. So this becomes x to the first, that bumps up to y squared. This becomes x to the 0, which we don't write obviously, and that bumps up to y to the third. So the pattern for the variables is easy enough. It's these coefficients that we need to figure out a pattern for. And this triangle gives us that pattern. So what we do is we have 1s going down on the right and left side, and then we add, in any row, we add two numbers, and in between, in the next row, we write their sum. So 1 plus 2 equals 3. 2 plus 1 equals 3. We keep going. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. And we have 1s on the outsides, on the left and the right. So once again, 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. And so on, and so on, and so on. And that gives us Pascal's triangle. And so this gives us the coefficients of the terms. So when I want to do x plus y to the 5th, I know the coefficients of my terms are going to be 1, 5, 10, 10, 5, and 1. Notice the symmetry involved there too. So let's go back to the opener now that we know the coefficients, 1, 5, 10, 10, 5, 1. And let's get rid of all this silliness. And let's fill in our coefficients, 1, 5, 10, 10, 5, 1. And now let's write the pattern for our variables. We start out with x to the 5th, y to the 0, which is just 1, so usually we wouldn't write that, plus, then it becomes x to the 4th, y to the 1st, and the x goes down to the third power, y goes up to the second power, x to the second, y to the third, x to the first, y to the fourth, and finally x to the 0, y to the fifth. Now we don't write the 0 and the 1 exponents, so we're just going to write our final answer as x to the fifth plus 5x to the fourth y plus 10x cubed y squared plus 10x squared y cubed plus 5xy to the fourth, and finally y to the fifth. And that's the expansion, and that was pretty easy to do instead of multiplying everything out. So Pascal's triangle is very useful. Let's switch gears for a minute. How many ways can I choose 3 students from a group of 7 to wash my car? Wow, we just took a strange turn. But let's just go with it and figure this out. I have 7 students to choose from. Let's call our students A, B, C, D, E, F, and G. There's my 7 students. How many ways can I choose 3 of them? Well, I could choose A, B, and C, or I could choose A, B, and D. You know, we could figure out a nice systematic way of coming up with a pattern A, B, and E, and then eventually we'd get down to A, C, and D, etc. And then eventually we'd be done with all the A's. We'd have A, F, and G. And then we'd say, okay, I can pick B, A, and C, and so on and so on and so on. So it seems like there's a lot of ways to do this. But if you notice, if I started writing all these out, and I'd look at some of them and I'd say, wait a minute, I chose A, B, C, and I chose B. That's the same group of students. So there really isn't a different way or a different group. So how can we figure out the total here? I have 3 spots, 3 lucky students to wash my car. How many choices do I have for the first student I pick? Well, there's 7 students, so I could pick any one of the 7. Now I've picked one of those 7 students. How many do I have left for the next spot? Well, I have 6. And then that leaves me 5 for the third spot. So 7 times 6 times 5. So 42 times 5 is what, 205 maybe? 42, yeah, no. 42, 420, 210, I believe. All right, but that doesn't take into account the situation where I'm really choosing the same 3 students. I mean, if I choose C, then A, then B, that's the same as A, then B, then C. So how many ways out of those 3, if I pick 3 of them, like A, B, C, how many different ways could I arrange those, the order that I picked them? Well, I could pick any one of the 3 of them first, then I have 2 left for my second choice, and then I have 1 left for my third choice. So there's actually 6 different ways that out of the 3 that I selected here, there's 6 different ways that I really have the same 3 people. So I'm going to want to divide that. So I have 7 times 6 times 5, but the order doesn't matter, so I'm going to divide that by 3 times 2 times 1. And so that winds up giving me 35. I have 35 choices of which 3 students I can choose to wash my car. Okay, so what does that have to do with anything? Well, in mathematics, this is a type of combination, and we have some notation for that. And what we use is a set of parentheses and 2 numbers inside of it. The number on the top, I'll call n in this case, and the number on the bottom r, and we read this as n choose r. So in the problem we just did, we're really calculating 7 choose 3. And we learned that it wound up being 7 times 6 times 5, and then divided by, it didn't matter the order of the 3 I pick, so divided by 3 times 2 times 1. Okay, so mathematically, how can I write this? Well, it turns out that n choose r is n factorial divided by r factorial times n minus r factorial. Where does that come from? Well, if we look at our example here, if I continued and said times 4 times 3 times 2 times 1 on top, and also multiplied that on the bottom, that's really the same answer. I'm just making it look more complicated. And so now the top I can write as 7 factorial, and the bottom I can write as 3 factorial times 4 factorial. And hence, that's where this comes from. All right, so let's try a few. I'd like you to evaluate 8 choose 5. So let's follow the rule. It's 8 factorial over 5 factorial times 8 minus 5 factorial, which is 3 factorial. So that's going to equal 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. 5 factorial, 5, 4, 3, 2, 1. And then 3 factorial, 3, 2, and 1. Well, I can cross this off with all of those. 3 times 2 is 6. That'll cancel with that. And so I'm left with 56. So 8 choose 5 is 56. If I had 8 of something and I wanted to choose 5 of them, and the order doesn't matter, there'd be 56 ways I could do that. Okay, let's calculate 8 choose 3. Well, that's going to equal 8 factorial over 3 factorial times 8 minus 3 factorial. But wait a minute, that's 8 factorial over 3 factorial times 5 factorial, which is exactly what we just got done calculating. Notice, those are exactly the same values. So this is going to equal 56 as well. So why is that? Does that make sense? That 8 choose 5 should equal 8 choose 3. Well, if you think about this as I have 8 people and I need to choose 5 of them to join a committee, that should be the same as if I thought of it as I have 8 people and I need to leave 3 of them out to not be on the committee. There's 56 ways I can do that. Okay. Let's try a few more of these. Calculate 5 choose 0. Now you might think, well, that doesn't make sense. So according to my formula, that should be 5 factorial over 0 factorial times 5 minus 0 factorial. Well, what's 0 factorial? 0 factorial is defined as 1. So it's 5 factorial over 1 times 5 factorial. And obviously those cancel and reduce down to 1. So the answer is just 1. Does that make sense? Well, if we use our choosing people idea, if I have 5 people, how many ways can I select none of them to join a group or join a committee? Well, there's only one way, and that's not to select anybody. So 5 choose 0 makes sense that it equals 1. And it also should make sense that that would equal 5 choose 5. If I have 5 people, how many ways can I select 5 of them to not be on the committee? One way, and that's not to select any of them. 5 choose 0, 5 choose 5. So in general, if I have, let's say, 42 choose 20, that should equal the same as 42 choose what? 22. So when these two numbers add up to our total, we're going to wind up getting the same answer, because when we use the formula, they both start with 42 factorial on top. In the denominator, this one will be 20 factorial times the difference between these, which is 22. Just like this one will be 22 factorial times the difference between these, which is 20. And so that's why, and that tells us the symmetry involved. And speaking of symmetry, oh, we saw some symmetry here in Pascal's triangle. All right, so now let's try, let's go a little bit more. Let's try and simplify. By the way, on the calculator, there's a way to do that as well. Well, why didn't you tell us that in the first place? Well, you'll see why in a minute. But to do this, it's in the math menu. So you press the math key and you go over to the probability submenu and you see number 3, NCR. Now, before you actually grab that command, you have to put in the n number first. So let's say I do 8, and then I go math, go over to the probability menu, go down to number 3, 8, choose 5, and we know this answer should be 56, and sure enough we get 56. Okay, so why don't we just use our calculator all the time instead of having to do this by hand? Well, that's fine, but now you go ahead and figure out that using your calculator. N choose n minus 2. Well, that's not going to work on the calculator. But if you tried that on the calculator, it'll, whatever value it has stored in n, that's what it'll use. One specific number, but not in general. So let's figure this out. This is n factorial over n minus 2 factorial times what? The difference between them. So n minus 2 factorial. So that's going to be n factorial over n minus 2 factorial times n minus the quantity n minus 2 is just 2 factorial. Now, let's write this out. What is n factorial? Well, it's n times n minus 1 times n minus 2. We keep subtracting 1, right? N minus 3, so on, until we get down to 1. Okay, in the denominator, n minus 2 factorial. Let's write that out. N minus 2, subtract 1 from that. Oh, that would be n minus 3, n minus 4, etc., all the way down to 1. And then 2 factorial is just 2 times 1. Look at all the common terms here. Since everything's being multiplied, we can cancel factors top and bottom. Those reduce down to 1, n minus 3. And all the way down, all these dot, dot, dots, all the way down till 1. So we're only left with the n times the quantity n minus 1 on top and 2 on the bottom. So our final answer, and you can leave it factored or you can multiply it out. I usually leave it factored. And so that is the answer for n choose n minus 2. Okay, we're going to stop in part 1 and then you can pick up on part 2.